All right, welcome back to Calculus 2, Applications of Calculus 2. We're going to do an Euler's method example here. So let's see, we have our dy by dx is equal to xy plus 4. We have our h set up to be 0 0.1. We have our initial conditions of y of 0 is equal to 0. So that means when x is 0, y is equal to 0. And what we'd really like to know is what is y of 0.5? Okay, I've got a couple other equations sitting here. Let's go through and kind of get an idea of what Euler's method actually is. So what we're going to do is we're going to say dy by dx equals some kind of an f of xy. So we have some differential equation here. Okay, kind of like xy plus 4. All right, and what we're going to do is I'm going to contain this back into differentials. I'm going to call this delta y divided by delta x is equal to f of xy. Okay, and then we're just going to go ahead and multiply by the fraction. So we're going to say this is delta y is equal to delta x times f of xy. All right. Now, what we have to finish off here is saying, okay, well, what's delta y? Delta y is y2 minus y1, and this is equal to delta x. Delta x is just going to be our h. Okay, so we could leave it as delta x. If you read a calculus book that was written, say, before 1980, they would write them as delta x is h. After 1980, I guess the typesetting got bad and they decided that h was a better choice than anything else. So we're going to use h times f of x, y. Okay. And then last thing we're going to do is we're going to solve for, we want our next y value to equal my step value times my slope, right? F of xy is actually the differential equation plus the previous y value that we're going to have here. So instead of going y2 and y1, we could do something like y next is equal to h times f of xy plus y, and I'll say present. Okay, the current y. Okay. And we'll just start going through this. This is an iterative process. That means we have to go through this a number of times in order to get the answer. But let's go ahead and see how that's going to do for us. So we have our initial values of x equals 0 and y equals 0. We're going to go ahead and calculate our slope here. So we're going to say this is going to be delta x. So we want 0 0.1 times f of xy. In this case, this was xy. So we have 0 times 0 plus 4. And then we're going to add this to the previous value that we have here. Okay, so we're going to go ahead and put that together. So remember, we're going to add, multiply, and then add again. And that's going to be our y next. Okay, so our y next is going to be, this is going to be 4 times zero point 0.1 is going to be 0.4. Add it to the previous value, and we're just going to get our y, or the second y is just going to be 0.4. Okay, because that's all we have for that. All right, now we advanced the clock, we advanced the crank one more time. So we're going to go ahead and deal with what's the next thing. Again, so my x started off at 0. In order to get my x2 or x1 here, because this will be zeros, I guess, my x1 is going to be x0 plus the delta x. So it's going to be 0 plus zero point 0.1. We're just going to get 0 0.1 here. My y is equal to zero point 0.4. So y is equal to 0 0.4. And then we're going to go through and turn this crank one more time. So we have zero point 0.1 times, and now I have xy, which is going to be zero point 0.1 times zero point 0.4. Let me put this in brackets because we have a plus in here. Plus 4 plus what my previous y is. Now my previous y is going to be 0 0.4. Okay. And that's going to be our next y. So let's go ahead and figure out what that's going to be. Yes, I'm using a much fancier calculator than you're allowed, but I'm not going to do it for anything that wouldn't be allowed. Okay, so you could do this on a regular scientific calculator. The only thing this is going to do is allow me to see things a little bit easier and show you what's going on for the video. So we're just going to say, okay, we've got zero point 0.1 times zero point 0.4. Okay, so we're going to get 0.04 here equals plus our 4. So plus 4. All right. And then we're going to say times zero point 0.1. So we're going to get 0.404 equals. All right. And now the last thing we have to do is we have to add our previous values. So we're going to say plus 0 0.4 and get our next y here. Our next y is going to be 0.804. Okay, so that's our next y looking at for that. All right, and now again, we're going to advance the thing one more time and we're going to see what happens. Okay, so let's go ahead and see. We turn the crank one more notch and we'll see what happens. So I want x is equal to zero point 0.1 plus zero point 0.1. So my x value, my x2, is going to be 0.2. My y goes back to being 0.804. So we're going to say that my slope here, my next point here is going to be zero point 0.1 brackets, and now I've got x times y, so 0.2 times my current y, which is 0.804, plus 4, all right? And then we're going to add it to our previous value, so that's going to be 0.804 in order to get our next value. So we're going to see what that is. All right, so we go through a little calculation here. So zero point 0.2 times zero point 0.4 equals plus zero point 0.4. I'm sorry, plus regular 4, not zero point 0.4. So just 4. Let's go ahead and delete that. So, oh, wait a minute. Nope. That's if that's not right. We want zero point 0.2. Okay. Zero point 0.2 times what's my current y is 0.804. Don't let me make that mistake. Okay. Equals. Now we add the 4. So plus 4. Okay. And that's the 4. That's the plusing the 4 from the differential equation. Now what we have to do is multiply this times our step value, which is times our zero point 0.1, which is going to move our decimal place. All right. And then what we're going to do is we're going to add that to the previous y value of plus 0.804. So plus 0.804. Okay. And that's going to be our next y. So we actually end up with 1.22008. 1.22008. At this point, you kind of have to decide how many decimal places we really want to keep. I'm going to go with 4. So 1, 2, 3, 4. And I'm just going to stop it right here. So we'll say this is 1.2201. Okay, rather than keep going out further and further and further, we'll just stop it at 4 decimal places. All right. Next thing that we have to do, we have one more step to go forward. Okay, turn the crank one more notch. So we have x3, okay, our third value. So we add 0.1 to 0.2. We end up with 0.3. My y value is now equal to 1.2201. Okay, and now we have to go ahead and calculate what's going to happen here. So we have 0.1 times, and we have a bracket of xy, so we have 0.3 times 1.2201 plus 4. Okay, and then we add this to the previous value, so we have to add it to 1.2201 and see how we go. All right, so let's go ahead and turn this around. So we'll do that. So we'll say we've got 0.3. No, we want 0.3. Brief. So we want 0.3 times 0.12244. So times point. Oh no, sorry, 1.22. 1.2201. That was the previous value we had. So we get that product out of the way. We're going to add 4 to the whole thing. So add 4. Then we're going to multiply this by 0.1. So again, we just move the decimal place, but sometimes 0.1 equals, and then we're going to add that to the 1.2201. So plus 1.2201, and that's going to be our next y value. So we can go ahead and say our next y value is 1.65. Let's see, 1.6567. 1.6567. Again, I'm going to stop it at 4 decimal places so we don't run up the entire page with everything. Okay, so that's what we have so far. All right. Next line down. X advances by 1. So we have our fourth step here. 0.4. We have our y is going to be 1.6567. And we're going to go ahead and calculate what's the next y value. So we have 0.1 times x times y. So 0.4 times 1.6567 plus 4, all of that times the 0.01, or zero point 0.1 rather, and then we're going to add it to the previous value of my y, 1.6567, and then we'll see what comes up to be what we see next. Okay, so we're going to say, okay, great. So zero point 0.4 times, let's see, 1.65. I'm sorry, 1.65, 67. Okay, so zero point 0.4 times that equals, we're going to add 4 to it. Okay, we're going to multiply it by zero point 0.1. Okay, because we're up there, we're down to about there. Okay, and then we have to add this to the 1.6567. So 1.6567, and that's going to be my new y, and that is 2.122. Again, we're going to stop this at 4 decimal places, so I'm going to say this is 2.1. Let's see, 2.122. We're going to round this up, so we could say 1.230. Go with it that way. All right. So, oops, sorry. Let's go to the next level here, the next one down. Next page for me, we're going to say x5 is equal, my x is now 0.5. My y value at that point is 2.123. Okay, and that's actually what they wanted to know, right? They wanted to know what is y of zero point 0.5. When I might get my x to be 0.5, my y is going to be 2.123. And that's going to stop us right there. We don't need to go further to compute the next one. We could, but why would you want to do that? Especially if you have, more efficient means to do this, like with a program or Excel or something like that. But that's pretty much how we go through and deal with Euler's method. And that's a very nifty way to be able to approximate a first order linear differential equation. If you saw the movie, I think it was Beautiful Figures, that was like the whole like thing at the end of the plot of like they were like, oh yeah, we could use Euler's method. And the reason why that is because back in the 50s and 60s, when people learned differential equations, they didn't really have computers. So doing things numerically was kind of a pain. So great care was always taken by textbooks to pick problems that the students could do analytically. That means with a formula, rather than have to do it with a computer without having to do it with numerical methods. Now the computing power is, first off, very common, and everybody pretty much has access to whatever they want. We don't have to care anymore. And of course, if you want to get a more accurate solution, I wouldn't have gone up by point ones. You could have picked your h to be so much smaller. Of course, it would take you a lot more steps in order to get to where we got to. But that's one of the ways to reduce the error is to takes much, much smaller steps. So instead of point 1, we've taken 0.001. It's very common that we'll pick something like 1 times 10 to the negative eighth, 1 times 10 to the negative sixth, something like that, and do it that way. And again, you wouldn't want to do this by hand. You would definitely want to deal with numerical. You would want to use a computer in order to make this thing work. Okay, so that's how you go through Euler's method. So thank you very much for being patient with me, and I will see you in the next video. And take care, everybody.